Welcome again, ladies and gentlemen, to the Simpkins Physics Corner, a little academic acceleration review today. Before you start, make sure you grab your equation sheet because that is the Rosetta Stone of figuring out these problems. So make sure you have your equation sheet with you. Let's rock and roll. Car goes from 0 to 60 miles per hour in 5.5 seconds. All right, so let's go ahead and underline our knowns here. What is acceleration in miles per hour per second? All right, well, looks like our initial velocity is going to be 0. Our final velocity is going to be 60 miles per hour. And we do that in a time of 5.5 seconds. Now, the question is asking us to find acceleration. So let's go to our equation sheet under Chapter 3. Go ahead and try to find the equation. If you notice, we have VF, VI, and T. I'm going to change this to VI. Sorry, I'm used to writing it like for another class. And we see this equation here, VF minus VI over T to find acceleration. So that's exactly what we're going to use. Our final velocity is 60 miles per hour. Our initial velocity is 0 miles per hour. And our time is 5.5 seconds. So our final answer here in miles per hour per second, basically how much is our speed changing every second that we go. If we do 60 divided by 5.5, we'll make our way to our answer. So 60 divided by 5.5 gets us 10.9 miles per hour per second. Basically, every second that goes by, we change our speed by 10.9 miles per hour. Cool, let's go to another one. A school bus can accelerate at a rate of 3 miles per hour per second. It is traveling on a highway at 45. It is, so that's the initial, right? So 45 miles per hour. Oops, sorry, miles per hour. It then accelerates for 7 seconds. What is its final velocity? So in this case, we're looking for VF. Well, if you can find an equation that starts with the thing you're looking for, more power to you. All right? In fact, if we look under our Chapter 3 equations, there is one right here. All right? And the equation says VF equals AT plus VI. So let's go ahead and see if we can solve for this. Our acceleration here is 3 miles per hour per second times our time, 7 seconds. And you'll notice when you multiply those together, the seconds cancel out because it's miles per hour per second times seconds. And then the VI was 45 miles per hour. And so if we can combine those two together, we just say 3 times 7. That would get me 21 miles per hour. You see how the seconds canceled again, plus 45 miles per hour. And we find that our final velocity is whatever 45 plus 21 is, which you can do mentally probably, is 66 miles per hour. That's how fast we'll be going later. Cool. Continue on. The car can accelerate. Okay, so again, we're underlining our knowns. A policeman sees a car accelerate for 4 seconds to pass a truck. The car is then clocked at 70 miles per hour by the policeman. How fast is the car moving when it first started to pass the truck? So it looks like we have our final speed of 70 miles per hour. Our initial speed is the one that we're trying to find. We know the acceleration is 8 miles per hour per second, and it takes 4 seconds to accelerate. Now, this one is a little bit trickier because just because the equation doesn't start with V initial, or VI, doesn't mean you can't use that particular equation to find VI. Let me show you what I mean. If we set up the equation we just used, VF equals AT plus VI, what we see here is that VI is kind of buried in there, but it's okay, we can unbury it. We can do a little algebra. So let's take a look. VF is 70 miles per hour equals, all right, so we have 8 miles per hour per second for acceleration times 4 seconds plus VI. So if we do a little algebra here, we have 70 miles per hour equals 8 times 4 is 32 miles per hour. You notice the divided by seconds and the seconds annihilate or they cancel out. And so our V initial, we'd have to subtract 32 from both sides to do the algebra here. And our V initial would come out to be 38 miles per hour. All right. The school bus in number 2, that one up there, okay, starts from rest. How long will it take the driver to accelerate to 55 miles per hour? So the final speed we're talking about is 55 miles per hour. And it says it starts from rest. The initial speed is 0 miles per hour. And it says up in number 2, it says the bus can accelerate at 3 miles per hour per second. That seems kind of slow, but maybe it's per second. Let's see what it is. 3 miles per hour per second. So it says how long. So here we're solving for time. Again, just because an equation doesn't start with what you're looking for doesn't mean you can't use that equation to find what you're looking for. If we look at the equation VF equals AT plus VI, we can see here, as we plug things in, our VF would be 55 miles per hour equals 3 miles per hour per second times T plus our VI was 0. That's convenient because what that means is 55 equals 3T, or if we divide both sides by 3, then our T would be whatever 55 divided by 3 is, which is going to take 18.3 seconds. So not exactly doing a quick quarter mile, but you are driving a bus after all. All right. Now, the next few here are very similar. These all have VF, VI, A, and T. So they're pretty straightforward. I will post this completed answer key for those, but I wanted to take some time to look at the next part of this set because these are the more complicated equations. These are the rest of the Chapter 3 equations, all these down here. So let's take a look at what we can find, all right? So it says we accelerate from this speed to that speed in that much time, and it asks us what's the average velocity. Now, this isn't on our equation sheet, but average velocity, you know the average is just add two things up and divide by 2. So I would say 1/2 of 30 plus 120, and that would get me 0.5 times 30 plus 120. That would get me to 75 meters per second. So that's our average velocity for that first part. What's the acceleration? We can calculate that. Acceleration is VF minus VI over T. So it goes it goes to 120 meters per second from a speed of 30 meters per second over 5 seconds. And so that would be 90 over 5, or 18 meters per second squared. Here's where things get interesting, though. How far did that object travel during the event? How far is x? So now we're solving for x final. Remember the rule. We can make x initial equal to 0 if they don't tell us specifically where we need to start. But let's make our list of knowns. We do have a. We know a is 18 meters per second squared. It says we know the v initial is 30, and we know the v final is 120. So actually, in this case, remember we said sometimes what you don't know tells you more than what you do know. Because we know so many things, we pretty much can use any equation that has an x in it. All right, so let's go ahead and look at this one that's on our equation sheet. Delta x equals 1/2, all right, VF plus VI times T. And if we use this equation, 1/2, we actually already did that, didn't we? 120 plus 30. Oops. What in the world? That's not cool. Did I bump this or something? Oh, dear. All right, let's try that again. Where were we? Down here? Okay. 120 plus 30 times T. Oh dear, do we know T? No, we know that too. We could pretty much use any equation because we do know that T is 5 seconds. All right, so times 5 seconds. And that's going to just go ahead and come out at 150 times 1/2. And then times 5. So it looks like we're going 375 meters in that amount of time. All right, student drops a ball. How long does it take to hit the ground? Now, we're going to get into dropping stuff all next week, but we actually can solve this with the equations that we know. All right, if we consider dropping something, it says that we start up here, x initial is 456 meters, and our x final will be 0 when we hit the ground, right? It tells us that our acceleration is, we're going to call this negative 9.8 because we are going from a positive position to a 0. So we're going backwards on the number line as we fall. And it says how long does it take to hit the ground. Okay, so if we look at our stuff here, we got x initial is 456, and x final equals 0, and a equals negative 9.8, and our v initial is equal to 0 also. So looking at this question, what we don't know is VF, right? So we're going to try to avoid VF when we pick our problem, and we do need an equation with T in it. Well, the only equation that doesn't have VF and does have T is our last one on our equation sheet. So 1/2 AT squared plus V initial XT plus X initial. All right, and so let's take a look at this one. We got 1/2 negative 9.8 T squared plus, here's where it gets convenient because our V initial, sorry, I always write it like that. Our VI here is 0. And what's 0 times T? Well, 0, of course. So this goes away and this goes away. And what we find is X final we can plug that in. Oh, sorry, x initial is not 0 in this case. X initial is what we set it as, is 4, 5, 6. All right, so I'm going to clean up my diagram over here so I can go ahead and write the rest of this problem, because if I clean up our math, what we see here is that xf, all right, would actually, that one would be 0 over here. Why? Because that's how we drew our diagram, right? And so if 0 equals negative 4.9, that's what you get when you do 1/2, 9.8, by the way, t squared plus 456, then we have to subtract 456 from both sides. So negative 456 is negative 4.9 t squared. The next algebra step would be to divide both sides by negative 4.9. T squared would be equal to some number, 456 divided by 4.9, which is 93. And then we would take the square root of both of those, and t would be equal to 9.64. Okay, so that's how long it would take the ball to hit the ground. You can see these get a little more complicated when we have more variables and we start to look at distance. How fast was the ball going when it hit the ground? This one isn't that bad. We're looking for V final, and we happen to know A, T, and V initial, so that's convenient. So how fast was it going? Well, it was just negative 9.8 for our acceleration. And do we know the time? Now that we do, 9.64, this gets a lot easier. So I would just do 9.8 times 9.64. Now, a little note here. We are moving downward, so that's why we have a negative velocity when we hit the ground. So our answer would be negative 94.5 meters per second. All right, so I'll do one more here for us, but I do have that whole set of more practice problem solving, so make sure you check those out. But I'm going to attempt, we got another couple minutes here in my 15-minute video, we'll finish this up. Car's traveling at this speed and sees a red flag. He starts to brake at this rate. What is the speed after this long? So we know V initial is 30. We can set xi equal to 0 because it doesn't tell us where we start. T is 3.4 seconds. And acceleration is negative 4 meters per second squared. It says, what is his car speed later? So we do need a VF in our equation, but we notice we don't have an XF. So actually, this one is not that bad because we're going to say VF equals A times T plus V initial. We have all of those things. We can use this equation to find VF. So negative 4 meters per second squared times our time of 3.4 seconds plus 30 equals 16.4 meters per second. All right, so that's the speed after that, 3.4 seconds of slamming on the brakes. Let's continue. How much time does the driver need to stop the car? So they're kind of changing the problem on us a little bit. We do still have the same acceleration because we got the same brakes, right? But now we're going to say our V initial is 30 and our V final is 0. Why? Because we come to a stop. We need to know that these words mean things. So if you're at rest or you come to a stop, in that case that would be V final equals 0. How much time? So we have VF equals AT plus V initial. Remember, just because the problem doesn't start with T doesn't mean we can't use that equation to solve for T. So if we look at this, we have 0 equals negative 4 times T plus 30. And to do the algebra properly, we would subtract 30 from both sides. We would say negative 30 equals negative 4t. Divide both sides by negative 4. And t would be 7.5 seconds. So that's how much time you would need to completely stop. How much roadway? So this is asking us how far is it going to take to stop? Well, let's try some of our x final equations. If we look, we don't know. Actually, we do know the V final. So really, you could actually use any equation you wanted to, because now we know the time as well. All right. So if you have a million different options, use the one that's the easiest. This one looks pretty easy to me because there's not that much involved with this equation. So I'm going to use this one, and we'd say 1/2. All right. So we got V final, which is going to be 0 because we got to stop, plus V initial, which was 30 because that's how fast we're going when we hit the brakes, and it took us 7.5 seconds to stop. So 30 times 1/2 times 7.5 equals 112.5 meters. All right, so this is about all the time I have for this video. I will post this answer key for you guys as you review today for our quiz coming up this week. You want to be very familiar with how to use all of your acceleration equations, and if you need extra help, you can go back to our problem-solving circle time lesson as well. Till next time, this is Mr. Simpkins in the Simpkins Physics Corner.